So welcome everybody. Do you hear me well now? Yeah, I don't have to use microphone. That's good. Today we're going to talk about Terraform and specifically how to manage AWS resources using it. So first of all, my name is Anton Babenko. I work in Telenor Digital as a cloud software engineer, working with AWS, DevOps, and different things in between. So by work, I figure out that we are using too much of different ways to manage infrastructure of AWS, and then I figure out that there is Terraform. So it's ended up me giving this talk now. I've been doing web development for the last 10 years, and I still enjoy it very much. So Terraform is native step for me to manage whatever I create using Terraform. So you can find me on any of these links, and feel free to send me an email. So during this talk, we should mention some companies who put the efforts into it. Of course, without this one, HashiCorp, it wouldn't be possible at all. So thanks very much for them. And code which I have prepared is hosted on GitHub. CodeShip is for those who are tired with Jenkins and constantly setting up something what you're not going to be used. So look at CodeShip. I really like them. But I have another sticker, which is their competitor, actually. And Telenor Digital is the company where I work now. So we are hiring, and if you like things like AWS, Java, DevOps, Terraform, and everything what comes along, feel free to contact us or me. And Telenor Digital actually sponsored this pizza, so thanks, my boss. Agenda, starting from zero. First of all, let's figure out what is state of things and why there is actually need of such tool and such talk. So then we'll go into Terraform 101, getting started with Terraform, and dive deeper with covering some more advanced techniques. At the end, if there will be people still interested, we'll have some demos and some like greenfield demo, which I'm doing right now, is continuous integration and continuous delivery using Terraform. Before we proceed, who of you know what is AWS and use it daily? Cool, so actually more than half. That's very impressive. That's good. And who of you know what is Terraform? Oh, even much more than half. That's cool. Then you're going to be very much into it. I hope you like advanced concepts. Okay, so getting started with Terraform is definitely going to be boring for you, but anyway, it's important. So let's start. So at work, I'm using Amazon Web Services for everything. And there are plenty of different ways how to manage infrastructure as code. The most native solution for most of us is CloudFormation, which is service developed by Amazon, which is supported by them. They provide new features themselves, and that's it. So natively, Amazon Web Services is the first one which comes to our head. What other options do you know what can be used for supporting Amazon Web Services infrastructure? What kind of tools do you use? Can someone say? All of you use CloudFormation? Hopefully not, right? So someone probably use Puppet, Chef, Ansible, Salt, CF Engine if we're in Norway. Right. I don't actually know if they support Amazon. But anyway, third native options, if you have a bunch of developers and you want them to manage infrastructure is to utilize some libraries in their favorite programming language, like Motor, which is written in Python, or Fog, which is written in Ruby, or just calling AWS API using command line interface or different SDKs directly. So in this case, developers will have to write their own code themselves and call specific features of Amazon APIs on themselves. And the last one, which is why we're here, is Terraform by HashiCorp. So if you are curious about what is Amazon Web Service CloudFormation, and you want to get better understanding of what kind of comparison I'm trying to make, like CloudFormation and Terraform, feel free to go to this URL. This is my talk 3 weeks ago about managing AWS infrastructure using CloudFormation, and you will probably have good understanding of that product. But today we're going to talk just about Terraform, mainly. So Terraform has been developed by HashiCorp. We may know HashiCorp by Vagrant, which came approximately 4 years ago as tool which is very much in use by developers. Packer can be used for packaging different images in predictable fashion, and some other components, which were all created by the same company. Atlas is one of the latest one, at least on this image, which HashiCorp developed. And Atlas is a combination of some of these tools, so that HashiCorp can make money. So for Atlas you have to pay, for everything else you don't have to pay. Terraform is open source. So actually I like this quote very much. It has been said by someone at some DevOps conference, which I have not attended, but I really like it. So HashiCorp is Atlassian for DevOps. We probably all remember what was Atlassian when they started. So everyone was thinking, wow, Agile equal Atlassian. And now when we say that there is DevOps everywhere, most of us, at least I guess most of us in this room, can understand that DevOps equal HashiCorp to some degree. And I think this is true. Actually, what is Terraform? Terraform is a tool for building, changing, and predictably, versioning infrastructure safely and efficiently. Safely and efficiently is two key words in this definition, because if you compare it to other solutions which were described previously, they don't have any guarantee that it will be executed safely or efficiently, especially if you call libraries on your own. There is no guarantee that it will actually be executed properly. So some facts about Terraform. As of now, if they haven't released anything during today, the latest version is less than 1. Some people can think that this is not ready for production, but it's not so. So it's open source and written in Golang. Who of you actually understand and can write in Golang? Cool, 1. Excellent, Vincent. So 1 guy can write in Golang and he can contribute. This is open source product. Actually, it's in very active development phase, because I count GitHub issues as one of metric of how active is it. It's not just 5-10 issues which created and people complaining about something not working or something terribly wrong. It's something created and closed, so which is good. Community is very much growing. The most active community is in ERC and the mailing list. Stack Overflow is not used almost at all. So don't expect a miracle there, really. You can ask some good questions on GitHub issues as well, but ERC is really an active one. More than 100 pretty much active people there. Good, I guess. So let's compare Terraform and CloudFormation as a main competitor of AWS infrastructure management tool. So yeah, this slide goes to be big. First of all, CloudFormation, we can start bottom up or somewhere. CloudFormation supports only AWS resources. And if you have some combinations of resources, let's say you use not Route 53, but you use something else, then unfortunately you cannot have all your infrastructure covered by one tool using CloudFormation. And it is totally possible to integrate more than 20, now it's approximately 25 different providers which Terraform can handle. It can be cloud providers, or it can be DNS providers, it can be even Rundeck. Some people ask in GitHub issues, what the fuck is Rundeck? How it appeared on list of supported providers. And actually it ended up that one guy who is working on HashiCorp wanted to have all resources managed using one tool. So he simply added that support into there. So it was, as I understand, pretty straightforward task for him. I guess you already read all of this. State management is, for those who don't understand what is state management. State is some file which contains description of your resources which can be managed. So if you use CloudFormation, you don't have actually any file which contains description of resources CloudFormation knows about. So some resources can be tagged, like EC2 instances, they will have tag. But not all resources are supported, and you cannot get list of resources. In Terraform, it is totally possible, and you will always have tfstate file, which contains pretty readable version of your resources. Execution control is a key feature of safe infrastructure management. This means that you can really make sure that execution will happen on specific subset of resources in specific order. Specific details will be changed, deleted, or created. So you can, in Terraform terms, it's called plan. CloudFormation doesn't support this. So if you created a CloudFormation stack half year ago and you want to do just small thing or just small modification, in most cases it will be hard for you to figure out, is it going to be safe change or not? Is it going to be doing a lot of changes or just small one which I want? Yeah. Any question on this one? Why I say yes, no, limited, yes, hard? If there are no questions, then that's fine. But if you have any questions, just interrupt me in the middle. I like it very much, really. Okay? Cool. So let's talk about specifics just in regards of Amazon Web Services. CloudFormation as tool which developed by AWS actually support more than 121 resource types. And Terraform on the other side 103, which is not actually apple-to-apples comparison, because AWS resource types is very vague term. You cannot compare it like one-to-one. So, but it gives you impression that Terraform is slightly worse than CloudFormation, at least in this graph. And each resource type has its own properties or operation. CloudFormation is not 100%. Even if you want it, it does not have all features supported, because CloudFormation developed by different teams. So one team developed one service, another team developed CloudFormation. They don't work in sync so much. And Terraform open source, so work in progress, will always be there. And people just add like crazy new features and new properties all the time. And handle failures, I put star here. This is just a reminder for myself to say that Terraform is extremely good at handling failures. If you execute Terraform and there will some conflicts, like some resources cannot be updated or deleted, you will have to fix it and retry, which is in most cases, which is much better than in CloudFormation say that if you cannot apply this stack, then please roll back. Because in some cases, in some terrible cases, with CloudFormation, if you cannot roll back, then it will end up with a state where you have to call AWS support or email them and say, hey guys, please help me. With Terraform, you're totally on your own and you have to fix it yourself. Fixing yourself is not so hard or scary because you know what you changed. And Terraform has clear agreement or clear goal that there should not be any resources which Terraform knew before or managed before, and then it simply cannot manage them anymore, and they will be like somewhere in your account, but Terraform cannot update them. Terraform will always keep them as a pain point for you. So you will not end up with some resource which is in your account, but Terraform simply say, I don't care about it anymore, leave it on your own. It will always tell to you that you have to do something, you have to delete it manually, or you have to specify some dependencies and so on. So Terraform has very good life cycle events where a resource has been added, then it means it will be treated very well until you say to Terraform that, hey, forget about it completely. AWS specific are mentioned in issue 28. This is a public Google spreadsheet which contains all features listed. And if you want to have some feature which is not supported by Terraform, but you want it, so you want someone to work, you just put your name there and hope people will prioritize your feature more. I see that, at least my experience is that I put my name on some of them and they were actually implemented. I'm not writing Golang, so I have to ask for people like Vincent to write Golang. So CloudFormation has this awesome tool which describe your resources. Find that you can learn these icons by heart, but it's probably not so easy to understand when you have 200 elements on one row. Labels are not supported and connections are not always so obvious. Comparing to Terraform, where you can get before dot, this is resource type and this is name of it. So yeah, just saying. Okay, this is part, is it still okay? You're still here? Okay, that's good. So no one fall asleep. That's good. So let's go into commands. There are a lot of them. We'll talk about just a few of them because they are most important. Terraform remote. Does anyone know what is it? No? Okay, good. I think, yeah, officially it's not promoted as like must-have feature, but I put it on first place because this is a command which you have to use when you begin to work with any project in Terraform. So what it means is that this Terraform TF state is your local representation of your infrastructure which Terraforms manage. And TF is your configuration file of Terraform. And this is your AWS resources which you have somewhere. So this command simply say that have this local state file copied or syncing into S3 bucket, which means that other developers can run the same command and we will all share the same state file between our machines. Terraform is very smart in keeping this file up to date. So if someone runs some modifications, it will push changes to shared S3 bucket. It can be other sources, of course, but S3 is something what is easier to understand and get started. So when you create new resource or updated it, it will push to S3 bucket, and other developer will not be able to override your changes or your infrastructure if he didn't explicitly fetch you, because Terraform will say, hey, you are actually trying to override it, so please pull changes and then write your plan command. So plan command is executing your Terraform config files, and it compares what kind of changes I should actually change. And it also talks to AWS infrastructure and making sure that the resources are still relevant. And Terraform apply actually doing two things. First, it apply whatever you generated based on these TF files into your infrastructure and actually pushing it to your local TF state file. And as I said earlier, it can also push to this invisible S3 bucket so that other developers can use the same state file. Refresh means, hey, go to Amazon and update my local state file. And destroy, yeah, simply destroy whatever you knew before. And taint, yeah, I didn't put any errors because taint is not doing anything related to your configuration file or your infrastructure. It all happens in just this file. Here you say that please forget about this resource. So next time when you run plan command, it should be treated as recreated. So this command can draw these nice graphs which I showed before, and run more. And warm up. Still here? Good. No one left. Good. So yeah, these two commands, you create bucket and you put version in. This is kind of extra measurement for you to not delete your shared TF states file if you have them in bucket. Or more questions. What is it? How many environments? Yeah, right. So let's now talk about some practical things. So we know what is Terraform, how to get some commands running. Before I demonstrate it in action, I just want to raise some question. How many environments is enough, and what is actually environment? And how many AWS region is enough? And also, how many people will be involved? And also, it's not so important actually, because yeah, if you can work alone, then you can work in 10 simultaneous. Yeah?
Question.
Yeah?
You mentioned that there is going to, if one developer wants to change something, and then it's not possible because they have to pull and merge the changes, but is it possible to track who changed what and purpose? Some kind of like Git or something similar?
Only if you put it into a continuous integration system, then you can put it on each commit will be treated as modification of this TF state file. But Terraform will not keep this information anywhere.
So
it will simply update all these things.
So you have to use some kind of external tools for utils and stuff like that.
Yeah, Terraform will not care who updated it. You can put this information if you need it. You can put this information. No, you can put it. But yeah, if information is shared on S3 bucket, then you simply, by enabling version, can see what exactly has changed, but who changed it and why changed it. it's up to your Git to ask. Yeah, so how many environments and how many AWS regions? Environments in this term is development stage in production, load testing, whatever you name. And how many AWS region? Probably 1, EU, Ireland, maybe 2. It depends. But for the demo, I will start with just one environment, which means we have some code or some infrastructure which we want to push in single AWS region. And how many developers? Again, okay, fine. For now, it's just me. But all code which I am demonstrating will be pushed on GitHub, and anyone can run it. So, how many Terraform projects is enough? Why I put this question here? It should be after I demonstrate it. Okay, let's do something more interesting. Good. Yeah, Terraform in action. Oh, actually, this is also a slide. Good. So yeah, let's say that for the first demo we don't have anything in our AWS account, and as you may know, we put resources in VPC where we create some subnets and we deploy some web application. Web application is extremely bad word in this case because it's single line HTML. That's what I come up with. So yeah, let me show it. Okay, you see it well? Good. So can I? Yeah. Okay, don't look in any other folders because I don't know how to hide them. Just look into Terraform AWS DevOps. So there is a folder called projects, and there are 2 projects, heavy and shared AWS. And I'm going to execute Terraform script. I can show you what is it so that you all understand there is no magic. This script is a short way of running commands like Terraform, and then heavy is the name of my application, production, and what I want to do is I want to plan. So first of all, it is possible to see what kind of changes Terraform is going to apply. Yeah, very good. That's what I. Right. We need to have some access keys. So let's run it again. So when I'm running plan, what it does is that it initiates a production environment, which means, it will be open for everyone, so you will be able to see it. But I can just explain that when you run plan, this magic script goes to resources which it knows about and update local copy of state file. And then based on start.tf files in heavy project, it decides what should be applied. And here we can see that it's going to create some resources marked in green, auto-scaling group, ELB, some instance profile, roles, launch configuration, and some other things. And it will actually use some user data to, so this is our web application. If we say that we're happy with it, it makes sense to apply. I can show, this is my AWS account. It doesn't have any resources before, so I should be safe to run this. And if I run apply now, Terraform knows pretty well how many threads to execute. If you can see on the right side, oh no, it was fast. On the right side here, it was several jobs which were executed on the same time. So this means that Terraform executed, I think, 5 or 10 simultaneous API calls. One of magic sauce in Terraform is that it knows very well dependencies of all objects, and it will create them in correct order. So, like in this case, we can see that the last one was autoscaling group heavy, which was created last because it depends on some other things. So here is these TF files which were processed, and TF-vars is values which are required for this environment. So environment called production, then file production.tf-vars. Yeah, and we can now see that something has been created, right? So ELB has been created, some launch configuration, and some other resources. Okay, this is the easiest demo, so let's don't spend time on it. And just show that that one instance is launching now, so it will be up and ready soon. And as we can see on the end, produce output. So output is something what we get as a result of execution of this. So it says that URL should be this one. So if we go to this URL after some instances finish launch, and then we should be able to see something there. It will be nothing special, so we can skip this part really for now. Again, if you have any questions, please just interrupt me, because I do this maybe too fast or maybe showing bad parts. Okay, so we have a project called Heavy and shared AWS. So if I show this, so this is the resources which were created by, yeah, this resources has been just created, and Terraform graph command can make such nice drawing for me. Shared AWS is another project which I made just for illustration, how different resources can be shared between different teams. For example, in some setups we have network team which creates some subnet, VPC, internet gateway, and that's it. But they don't want their developers to do anything with these resources. So they are exporting these resources for them in read-only mode. So this is the way how I do this. So shared is another project. I executed this project before, so that's why it didn't. If I run it now, it should say that there shouldn't be any changes because it's all good. Yeah, no changes. Thank you very much. Okay, so next one. So what are the ways to structure configs? Configs is filed start.tf. Okay, first, if you have small project or you just want to get started with it, you probably will make one folder, put all things into one place, and that's it. This is very good for small setups where you can just create all resources, delete all of them. No dependencies, no separation by teams. It doesn't matter how many DevOps you have. It's just fine. For bigger and for more common use case, I see separation by environment means that you have, like in my case, I demonstrate that we have heavy and shared AWS. So there are two projects with one environment each called production. Another way is to to call project the same as environment. So you will have project called production, project called development, which for some cases is good, for some cases it's pretty bad. For example, if you want to have some resources to be equal in all of your projects, for example, all of your developers, staging and production should have very similar amount of infrastructure. Let's say all of them have ELB, auto-scaling groups, and no exceptions. Then this is probably a bad way, because this gives you flexibility in parts where you don't need. You can add different components where you want, or it will be hard to to maintain on some degree. And read more is because this is one of officially proposed way by HashiCorp. I don't really see how cool it can be, but they propose it, so that's why I mention it here. I wouldn't use it for different setups, for different reasons. As I specified here, that each environment may contain different modules, means that you can have some modules enabled in one environment, but in another environment it will be different set. So it's up to you how to combine. What I find much more practical is when you have separation by not by environment, but by reason, right? So some networking thing is something what will be consumed by everyone. Each development team, each development unit will deploy something in VPC, right? They all will use, let's say, shared S3 buckets. And remember that everything should be managed as code, so you have to put things like buckets, code deploy application, Route 53 zones, all in code. So that's important to be able to access it in read-only way. You don't want developers to be able to destroy something what other teams are doing. And using layered projects, it's impossible because you have only read-only way. And you have to use modules to apply changes, like one change which will be applicable for all. And by having layered projects, you can actually make layers very small, so that networking is defined once in one module. It has very small changes periodically, but development team use their own project which defines things just they need. So it will be a very small network and very big application. Like in my case, it's called Heavy. You can see inside web. So the definition of different resources. Here you can see security group, template file, launch configuration, and so on is here, while inside VPC, I'm calling just 3 modules, calling VPC, Internet Gateway, and public subnet. That's all what I need. And then these variables are exported so that other teams can access, hey, what is my VPC ID? Cool, this is it. What availability zones I support. That's it. Yeah. If no questions, then we continue. So how to structure configs? Yeah. I probably have to open it like this. Yeah. Okay. It can be very hard to understand without practicing it, but it is important that when you introduce new environment, then there will be much more combinations production in for one project in Ireland, and production for another project in Southeast 1, for example, AP Southeast 1. That's already 2 combinations, and so on. So it can easily grow very badly, and you cannot manage them without tooling. Yeah, so when you have one and all, then you actually have 1 Terraform state file per environment. So I think this is easier to understand and easier to get started. Also, when you're working on something what you share with other teams, it can be S3 buckets, elastic IP addresses, IAM users, groups, permissions, whatever, or code deploy applications. Make sure that these resources are defined once and does not belong to any environment, because this will really simplify your life if you want to access these resources from one project in read-only way. For example, you want to define code deployment group, but for that you need to know which is code deploy application ID, and code deploy application is just one copy of it. You can also use environment in resource tags, so if you have a lot of resources, you can easily find them. Unfortunately, not all resources of AWS support tags, so it's not so cool feature, kind of. And use modules to be able to reuse whatever blocks, whatever blocks people created. Yes, so modules. Modules in this file, so you can see how modules are calling. So module is just like group of resources. So what you have to provide is source, where to get it from. It supports versioning, so which means that if Terraform community will be able to produce several tags and say that version 1.0 is not compatible with version 2.0, there is a way to do this. Terraform community modules is very young organization where we push whatever things other may need. For example, you don't have to write your own creation of VPC just because you can. So simply copying this block and say which VPC seeder you need. This is all what you have to do. The same for internet gateway, public subnets, and there are much more modules developed. So just go to this GitHub page and you will see how to do them. Yeah, so community modules are there. Okay, now let's figure out next thing. So everything what we saw before was not so interesting because you could make it in CloudFormation, right? Because you can manage some resources using CloudFormation, to be honest. But what you cannot do in CloudFormation is that if you have created some S3 bucket or some elastic IP and whitelisted on some places, then you probably don't want to lose it, right? And using CloudFormation is not possible because CloudFormation cannot import resources which it didn't create. So using Terraform is possible to achieve this, but it's not described in the book or in documentation. So what I'm going to show now is kind of my way to do this because I think it's cool, really. I don't know if you actually need it, but maybe you will need it. Again, you have created some S3 bucket and you managed to aggregate some files in it, and now you migrated everything into Terraform, and then you realize, oh my god, I have this this super bucket with, I don't know, some files in it, but I cannot delete it and create it again. So let's see, this is my magic, this is my magic bucket, and I'm not going to write a lot of files from scratch, so I will share this. So what I have here, I have definition of resource which is called Terraform AWS DevOps Demo. This is exactly what I have here, right? So if I now run this, plan command, it will probably look pretty good. It will say, hey, I'm going to create this bucket for you. But no, don't create this bucket because I already have it, right? And I have important files in it. So I cannot drop my bucket and then let Terraform create it for me, and then it will be managed by Terraform. So some magic should be applied here. So the magic which I normally do, I did it for Elastic IPs and for S3 buckets, but principle is the same. So I'm going to create another bucket, and I just give it another name. The reason for giving it another name is that I can then replace name, and then I will pretend that I have this bucket. So this Terraform TF state file is description of all resources which it knows about. It's pretty readable, but it's not recommended to write so much in it. And again, this is JSON. If you like JSON, go and edit CloudFormation files, right? That's simple. So if I run plan now, come on, we will see that it tries to create bucket demo new. Okay, cool, that's what I need. Apply, no refresh. No refresh is just a thing to not go to Amazon and fetch my resources again, because right now I didn't modify anything, so I can save 5 seconds. Apply no refresh. It will create this bucket because this is what it just planned. Cool, and it says that it says Terraform AWS DevOps bucket. Cool. So object has been created. If I now look here, this is my bucket. Cool. So we can see that it has updated state because the resource has been created, which is cool. But that's not the bucket which I want, right? So just create another bucket here. So what I have to do is very magic. Okay, it looks good, right? So what we say that, hey, Terraform, you simply forgot that you actually made this bucket. No, but Terraform is not so stupid. So Terraform will say that, hey, but you're on version 25. But I know version 25 had another bucket. So we say, oh no, but you actually forget this is version 26. And now it will work. So if we now run this plan, again, plan for planning, like this, then it will go and say that bucket should be created. That's because we didn't change it in this place. So our resource definition is now pointing to the right bucket, which is Terraform AWS DevOps Demo. And if we run, no refresh, just to save 3 seconds this time. So no changes needed. Correct, because this is bucket which I want. It contains a very important file, and means I can simply delete new bucket. So yes, I can verify that it knows about things which it should know. If I output, then I see that value Terraform AWS blah 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 is actually pointing to the right place. This is what I need, because image which I have in this bucket is very important for me. That's important image. Okay, so we can also verify this by drawing this resource just appeared and it's represented in this graph. Okay, if you are still into this, then I can demonstrate some more things which Terraform does not support, but you still need them. Because to my understanding, Terraform can manage 100% of resources which are available on AWS. And for that, you have to use some things like I just showed. You have to modify some files here and there. One common thing is that it has support for resource, but it doesn't have support for all properties. Like in this case, I have created ELB, and it has 443, and it supports all ciphers. I mean, it's predefined security policy. Sounds cool. I mean, most people use it, but in Telenor Digital we use some subset of these ciphers, so we cannot use default one. We need to limit it a little bit or extend. I don't really know. So you can run Terraform to create ELB to define these ports, but you cannot modify ciphers. Terraform does not support this out of the box. So one thing which I can demonstrate is inside. No, it's inside. So let's look at this resource definition of AWS ELB. So we have pretty standard way of name, subnets, and so on. This is all well documented. This is a magic place where we have to execute something. So what it does here, when this ELB is created, it will use all these variables the way we define, which is fine for significant part of cases. But provisional local exec will be called when this resource is created for the first time. You can hook at the end of it and call whatever you want. You can access properties of this own resource as well as any other resources available prior execution of this command. Like in this case, I'm calling AWS ELB to create some policy, and I'm referring to this property, which is actually just this name. And I'm also using this name here. One pretty bad part to my mind, but anyway, that's how it is. It's going to be executed just once when the resource is created. So if I now change something here and I want to say interval not 15 but just 7, and I can run it will say that it has to change just one value from 15, you see interval here, to 7. That's not what I want. I want to apply a lot of other magic changes, which is not supported. So for that one, I have to tell Terraform to, hey, this resource is obsolete. Please mark it for recreation. And Terraform will be smart to figure out how to do this. Terraform, yeah, right. maybe I have to taint auto-scaling group because this ELB is referred from auto-scaling group. So if I run now plan now refresh, it will say that, oh cool, there is new auto-scaling group which I have to edit. So minus plus means it will delete and then add new one. And the same for ELB. Before I execute this, I just want to show that on Cypher, all this is set to predefined security policy. So if we now run apply or refresh, it will be pretty fast. Maybe. No, it will be not so fast because it's going to destroy all auto-scaling group. And actually it will destroy all instances which are in this auto-scaling group. You can say to auto-scaling group that if you're going to be deleted, don't care about instances which were created. This will be faster, but it can potentially create some zombie resources which no one manage. So it's not very much recommended officially. Okay, yeah, it shouldn't be so slow actually. But we can see that it's doing something in several jobs. So it executed 7. Okay, anyway, when we're waiting for this magic to happen, we can probably see something else. So this resource ELB heavy is about to update. Yeah, cool. So starting from here, so it destroyed and then it created a new one, and we can see that provisioning with local exec has happened. So it ran this command locally using my AWS CLI command. And if we go now to this page, this is how it was before. We have to update this page. And now click change, and we see that it select another set and it select a custom security policy. So this means that if a resource type is supported by Terraform, but just small properties which are not so popular for most of use cases are not yet supported, you can use local exec. Yes, it has some drawbacks like the one I mentioned, but it is possible to use it. And again, go to GitHub issue number 28 or make new one and initiate discussion that, hey, this is what I would like to have, and maybe someone will be able to help you. I know people are helpful, really. So let's put it back. No. Why I should put it back? It can stay. Okay, so this was another demo. As we can see, ELB has updated some property. Cool. Can CloudFormation do this? Yes, it can, but it's very hard. Okay. When I said earlier that Terraform can be used to cover 100% of features which AWS has and will have, I assume two things: that these new features are supported either in the API, which I have just called using this command line interface, or using CloudFormation. For example, so Terraform is a pretty big community. A lot of people produce new code, new features, bunch of providers support it. But actually none of them thought about that let's concentrate and make Redshift support in Terraform. So there is actually a solution for this, that you can mix two technologies, one which supports Redshift and another which is cool. Okay, so you merge CloudFormation and Terraform. And we're going to add these two things. So Redshift is not supported by Terraform. This is not native resource. But CloudFormation, on the other hand, is native resource. So what I'm going to do now is I probably need to copy these two files somewhere here. So what these two files do, this is CloudFormation template which I steal from their website, which is big and which does something. It calls some Redshift cluster, which I mean, this type is unknown for Terraform. But that's good. Terraform knows about CloudFormation. So I define that I need some security group and I need CloudFormation stack with some parameters which will be passed into this CloudFormation. And again, as a result of this, I need Redshift endpoint which I can give to developers. And as you can see that it has outputs cluster endpoint because it's defined here in this CloudFormation template, cluster endpoints here. So let's plan refresh. We see that it's trying to create some security group and try to create CloudFormation stack based on this template file. Cool. I don't mind. No, actually I mind because it will take like 5 minutes to create a Redshift magic. You can specify it to not wait, and yeah, it is possible. CloudFormation resource type is pretty new as well, so it has some problems, and if you are going to use the really advanced feature of CloudFormation, you will end up with pretty bad situations like password will be displayed in plain text, but CloudFormation has this support. So these two boxes should be now updated. So while it's doing something, we can probably have a production graph. We can generate graph for the image, for the heavy. Oh no. So these two boxes are already there, but it's not created. Because this image actually represents not current situation and not resources which already created, but this image is drawn from Terraform config files. So if you are writing some config files and you have some strange situations, you don't understand who is dependent on what, you can generate this graph anytime. And yes, it can be hard to figure out, to follow lines and so on, but it gives some information at least. And if you have smaller projects, but let's say layered approach, then you have separation between network and things, which is, I can show while it's doing something. So this is networking thing, which is just about internet gateway, VPC, and subnet. So that's it. And actually this S3 bucket. And this is all related to just application. Yeah. So yeah, actually I forgot to mention that it will take ages, but it will be working. Redshift. Actually, it was hard time for me to find a resource which is not managed by Terraform, but available in CloudFormation. This one and maybe one more. All other resources, yeah, you can see that it's create and cluster here. Create, yeah, right. So it will take some time. Okay, any questions meanwhile? No questions. Can it be because it's dark?
So
You're sleeping?
In your practical work with Terraform and deploying applications on Amazon Web Services, you never found any resource in practice that you couldn't use Terraform with about this specific CloudFormation?
No, actually CloudFormation we didn't use. I mean, mix of this.
Okay.
What I'm showing now, we didn't use in production at all. So what we had difficulties with was not related to Terraform. Was more about how to organize separation between different projects, environments, how to call them. Should be there mix between development in Ireland and development in Southeast one, or should there be just one development? So, and we are leaning towards simplifying things so that there is one development in one defined region. There is one staging in region close to production, and there is one production in one region. We can always extend it. We can say that today there will be development, development Asia or development somewhere else, but it is possible, but there was no need. Technically, there were no challenges which we could not solve, really. Yeah, good question. Well, I answered, it created something. So we can see that Redshift endpoint is available. Also, we can load the super page. Oh, it doesn't work. Anyway, I don't care now. So yeah, here we can see that cluster is available. Mixing of these technologies like CloudFormation and Terraform, maybe not the very nice thing to do, because you cannot easily apply the same execution flow for them. So you have to, let's say, update stack, but you don't control this execution flow. But just for small things like single unit, like one Redshift cluster, that's it. I think it works fine. Yeah, so we see that we have created some resources. We illustrate this. Let's look further a little bit. We're almost finished, if you wonder. So demo summary, cool. Again, Terraform can create new resource and manage them. Also, Terraform can import already valuable resources like Elastic IP, S3 buckets, code deploy, application, IAM users, even key pairs it can do, but CloudFormation cannot do. This is one thing which differentiates these two technologies quite much, is that even if, let's say, you open a new AWS account and you think, cool, I will delete this VPC now and I will do everything using one tool, which is called CloudFormation. Excellent, I mean, good, ambitious plan, right? So you start using it and then you realize, oh no, I actually cannot create some resources like key pair. I mean, in order to create key pair, you have to go to console, say generate key pair or import key pair. So you have to do something else. It's not written in your CloudFormation template. Using Terraform, the only thing which you will have to do is edit some file on your computer. It can be config file. In some more extreme cases, it can be state file. You will have to call some APIs and so on. And yeah, as I demonstrate, Terraform can add missing resource types properties and missing resource types completely. So I think this was it for the most kind of most established part in our life and work. This is something what me and Orion, who is sitting there, we are working on this Terraform magic most of our time, and we have good time. We have a lot of difficulties, like at the beginning. Mainly, who knows what is cycle error? Like you try to delete some resource and it says, oh sorry, there is cycle error. Cycle. I mean, it's reference error. So this is happening when you try to delete a resource which has dependencies on another resource, and so on. The solution for this is described in documentation, but not completely. The very last step I figured out 2 hours ago is like, okay, you have your own resources like auto-scaling group, launch configuration, ELB. Just to simplify things, these 3 types of resource. And you say that, okay, I want to, so before I came today, I deleted all what I did so that I demonstrated like from scratch. So I wanted to delete it like using normal way, normal command, which is called Terraform destroy. So when I run this command, it says that I cannot destroy because there are some references. Okay, so by going one to another, I figure out that I remove this reference. So if I say that destroy, it should now delete everything. And the only resource which it cannot delete was called Terraform resource state file. I can show you here. No, it's main. This is Terraform resource state file. Is pointing to another layer of your infrastructure. Like in our case, it was application and shared AWS. And if I say that I want to delete all my application, it says that fine, I can delete this, but I should also delete all layer beneath, and that's not what I want, right? So I mean, you want to give developers read-only access to your bottom layer, right? You don't want them to delete everything. So the solution for that magic looks like this. That you have to go and explicitly specify targets which Terraform knows about, but do not include target which is called target Terraform shared state shared dot, yeah, that's it. So if I specify this target, then it will go and try to delete the whole layer beneath, and that's not what I want. So this bottom line is not needed. And this is not described in documentation. When you ask like what were challenges, some information was not in documentation. Some information was much easier to understand by just reading tests. This is open source project, so tests are pretty good, pretty meaningful. So I want to demonstrate some greenfield things, since this is kind of DevOps meetup, and most of us know what is continuous integration and continuous deployment. We probably should figure out what is, I mean, which part we can put Terraform into these pipelines and into all this continuous process. So let's see. Okay, we can have this resource as well. Okay, let's see where to start. Right. Does everyone familiar with Git flow, continuous integration, pipelines, and so on? So I mean, it will not be like totally boring. Okay, that's good to hear. So yeah, Git status shows good. As I showed at the beginning, that there were some cool sponsors, like informational sponsors, of course, but GitHub and CodeShip. So this is project which I will make public pretty soon, and just to put it like to more real situation. Let's say we have to have production in master branch. Okay, so sorry guys, there will not be any cowboy style anymore, no force push into master and hey, this is the way how I work. Look, it doesn't break this time. So we simply lock this master branch and no commits are allowed into this branch. So everything what I'm showing here is possible to do using any other CI tool that's not limited. I just picked this code chip like several months ago because it was cool and easy to get started. Okay, so if I now git checkout, okay, git stuff. Okay. So what I'm going to do is that I'm going to apply small change. I'm going to try to work with things which I make in real way. So we have some infrastructure. We have created. Let's verify that it's still working. You're right. This URL has changed because we applied different ciphers, so it has created new one. Right, so this is super intelligent application. It shows CPU usage of that machine. So let's say it's 0 now. It's kind of boring, right? So this is our let's connect to it. Let's do some load on it. Okay, here we go. So this is our real stuff. Again, we make this auto-scaling group with auto-scaling from 1 to 5, and there are no policy because time when I created this, there were no users, and now my application went viral and I get some traffic on it, and then I start to panic because oh my god, CPU usage is 100% now. Cool, that's what I need. Because what I want to do now is that I'm gonna to add git. Where is it? Strange. Well, I have this. Okay, I have prepared some. Maybe I forgot it. Maybe I forgot to push it. So, I'm on wrong branch, right? Okay, yeah, this makes sense because this is what I need. So my application is having a hard time now to use some CPU, and it's not scaling because there are no scaling policies. It simply doesn't know what to do. And so what I'm going to do now is I'm going to apply these auto-scaling policies, and it looks a bit scary because a lot of files are modified and I have no clue why they're like this. So I'm defining auto-scaling policy, and I connect them to CloudWatch metrics. So when in this situation, when average CPU usage of auto-scaling group heavy will jump above 80 during a minute, then it should call this auto-scaling policy called heavy out and add one instance, and then wait for 10 seconds before considering adding new. Right, so if I now run this plan refresh, what? No, it's totally possible.
Yeah, you had a bunch of merge conflicts, so that's probably.
Oh, yeah, right. Okay. Then it's better to do. I think it's too much. Yeah, right. It's better to git checkout. It's better to do it on master branch. Switched. Auto-scaling policy. Right. So I now make another branch, and I just have to call it feature starting from feature. That's why I pick up the old one, which was ancient. So I call it ASG, auto-scaling group, and probably it's better to do it this way. Cool. So if I now plan, then it will complain about some resources. I mean, it's fine that it tried to delete something because we don't have CloudFormation stack anymore, and ELB changes should be changed. That's fine. So it can be recreated. The only thing which we have to pay attention is that this new resource will be added now. So just change this to 7 to say that it was like this before. And then we don't have changes in ELB anymore. Cool, so in this case, Redshift magic will go away, and some new magic for my super popular application will be applied. Actually, another comment about refresh statement. As I said at the beginning, Terraform will not let you to do bad things on purpose. So if you try to apply changes but forgot to run refresh, it will not let you do. It will say that probably you forgot refresh. It will actually say it in a bit magic way, because it will say version mismatch, but you don't know which version, and version between local state file and remote state file. Yeah. So again, all of this initiation of these resources has started at the same time, and now they are all in queue. It's not one after another. Cool, we already see that it has just created these two CloudWatch metrics, where we can see that actually the first one already crossed the red line because CPU usage jumped 100%, and probably should go down because we're going to add new instance and average will go down. We can also see this somewhere here, that new instances are being added, and that's all because on this page we can see that new scaling policies has been added. Again, all of this we manage through code. So if normally I apply this this change like from my computer, this is probably not the best way. What is good way, and what I actually was about to show, is that when you now I cannot stop because it's doing something. But what I wanted to show is that I actually protected master branch, and I work on feature branch, which which is the way you should be doing. You are working on one feature, you think how cool this feature is, you evolve it, commit continuously, you see new plans happening for that feature. Let it finish, and then so what is taking time now, I'm guessing, is deletion of Redshift. It takes ages to get it up and get it down. Oh no, actually destroying. Oh, you're right, destroying doesn't mean that it's destroyed. Good luck. Okay. So while it's doing something, I can just open it here, so when it stops, then we'll switch there. So on CodeShip, I specify that if feature branch is in use, that new commit is pushed to this branch, then I want to plan changes in this branch towards production branch. And I just want to see a plan. I don't want to apply this plan right now. And when this feature, when this change actually makes sense for me, then I want just this specific change to be applied. Just this, not anything else, not some cowboy style which will just throw this in addition, you know, hey, and this is my small fix, like just in case. You can actually lock Terraform plan so that everything what Terraform planned once, you can simply put into one file. And then you put this file as parameter for applying. So this gives you a very good control mechanism that you plan something, you verify it visually, then you say, okay, this makes sense, and then you apply this change. So yeah, while it's doing something, one of my suggestions is to not interrupt it. Because if you interrupt it, it will first say that, are you sure that you want to interrupt it? And then you say, yeah, I'm sure because I know what I'm doing. No, you actually don't know what you're doing. Because it will corrupt, it will create some resources. And just in the middle of this creation of resources, it will interrupt you. I mean, you interrupt it. And everything what should have been finished will be now your problem. So what is a solution for this, as my understanding, is that you have to delete these resources which Terraform just created and start from scratch again. It will do its best to continue execution, but it's not always able to find which exactly step it has passed. Though state file will be updated once single resource is created. So one resource updated, state file updated. Sounds cool. I can show you. If I stop it, interrupt received, gracefully shutting down. No, don't. I mean, it will not do it gracefully. If I click Ctrl+C once more, then it will give me some work. You can reduce this amount of work by saying that, hey, mark this resource as tagged, and then Terraform will try to redo this resource once more. So I have no clue why it's taken so long time, really. Let's see one more time what it was about to do. CloudFormation stack, let's see. CloudFormation, where are you? Delete in progress. Yeah, exactly. So that's the most craziest part, is being dependent on from one technology on another technology. And delete in progress. Yeah, I can. No, I don't see. Yeah, cool. It now finished. Oh my god. Right. So destruction complete. Excellent. Actually, this is one of the funniest part. If you interrupt CloudFormation, then CloudFormation can have big chances of ending up in situation update rollback failed, which means that it wanted to go back, but it couldn't, and now you don't have anything working. This is like the worst case ever. Okay, cool. We have no CloudFormation. We have some CloudWatch things. And while we were waiting for CloudFormation to do something, our application, let's see, our application is just growing and growing because our load is big, right? You can see how big is it. It's not so big. It was big. It was big some time ago, and then it went down because too many instances started probably. Okay, back to continuous integration, continuous deployment part really. Just let's say this is changes which I want. Git push origin feature. Let's go. Cool. So let's figure out that this is new feature branch, and in this continuous integration we can see that it's already executing some commands on it. So this is very similar to Travis and yeah, all other hosted things. It bootstrap some dependencies for you and check out this version and execute whatever you need. It usually works pretty fast. So this helper script to set up CI environment, as well as all other code I will put on GitHub, so you can see it there. And it tried to do, so it says that shared environment tried to do this magic to delete bucket, and it failed. Actually, we didn't touch shared AWS production for quite some time. Yeah, and we can see that it's really trying to delete this bucket. So if I now, so the purpose of this thing is that I want to have a green build here. So my feature branch should be really green, right? Before I can merge it somewhere. If I now try to push to master and say, hey, this is okay to make it fail, no, it's not allowed. So I have to fix it, and fixing by applying it. Demo, bucket not empty. Right, so this is another dependency. My bucket contains very valuable files, so it cannot delete the bucket. This is a limitation not of Terraform, but AWS. So if I now delete this file, it can delete the whole. Right. So and if I now rerun this thing once more, just to show what is happening here. So we have different projects in one environment here, shared AWS and heavy, and on feature branch we just plan, and on master branch, because this is what makes sense, I apply these changes in addition to plan one more time, just in case, because it can fail on plan stage. And it plan again because it wanted to do what? Ah, okay, it's not a... Anyway, the magic, I guess you understand more or less. Right? Or not? So yeah, again, this was a greenfield project, so don't think that this is always so strange and unpredictable. I mean, when working with Terraform, that one error in one place, and oh, I forgot to change something in another place. When you figure out what's your boundaries, it will not happen so often, like today. You can see because yesterday I had a lot of success. And let's destroy in 2 hours, failed. No, this one. Actually, cold ship becomes slower on evenings because it's US service and it's getting much more attention on evenings. Good. So at the end of this magic, wow, so this is kind of instant notification. When I was testing it, it was always 5 minutes later. So it's really instant. If we now look into pull requests, then new pull request arrived, which means that, yeah, this is my feature branch, and these small changes, which I verify, and yeah, looks cool, you're smart, so let's apply. Delete branch. So now it will just apply these changes, and that's probably it. If you always have as a habit to work in feature branches, to not do force pushes on master, I think systems like this will really put infrastructure as code on totally different levels, because you see what's going to be applied, you confirm that yes, this is what I want, and then you just apply it. So yeah, apply happens, cool, merged, and we can see that this commit was verified, so which is good. We can go to yeah, to see some details here. Does it still create some instances? No, it scaled down because the instance which contains stress was terminated itself, which is kind of self-destruction mechanism. Right. So yeah, this is last slide, last meaningful slide on this presentation. On this greenfield project, using feature branches can simplify life so that you always follow the same routine, the same process, and iteration is much smaller. And lock master branch, when I first tested this feature on GitHub, I thought that it's not going to be used, or it will be hard to convince some old style cowboys, you know, who just force push to any directions. You know. Actually, this works fine because they can have fun in feature branches and validate it. We didn't do these things with continuous integration on a project where I work in Telenor Digital, but it will be in use one day. And if just applying or planning and applying these changes is too risky, then you have option to export this plan into out file and apply this out file later. So for people who like Jenkins, I don't know if there is any. No one. Yes. So there is Terraform plugin, and if you really like to be like these guys or girls or animals, you are very limited, right? So you have some access to things, and you can just push buttons. If this is what you like, then there is Atlas. Atlas is a commercial product from HashiCorp, where you combine tools like Packer, Terraform, and some other, and have pretty good user experience, where you can put things like define your own pipeline, so that certain steps has to be validated, it has to be integrated with some Slack notifications, and so on. So it has a bunch of things, but it's big product which definitely will take time to get to market. Now I don't see anyone who can use it right now. So summary, Terraform is cool. Any objections on this? No? Then we continue. So, any questions?
Talking about you're keeping the state file in S3 bucket. Does that can you lock that file? Is it locked somehow?
If you're thinking that different people have to have different access to different different state files, you have to do this on Amazon level. So you have to don't give permissions to IAM users to read this file. This is kind of one approach. And another approach is that you put them in different buckets completely. But again, it's all on Amazon site. Terraform does not have this control. Yeah.
It's not a little bit strange that it doesn't provide sort of remote state. You can query APIs about the state of your
no, there is work in progress on this. This kind of feedback has been heard many times, and I think it will come pretty soon. Another challenge with state files is that config of state file and state file itself is one unit now, and this is very hard to separate. Even like this, if you have access to file, I mean, previously it was a case, and I've heard about it on some places. People say that state file is not actually guaranteed to be safe because it can contain some secrets. And this has been solved to some degree. So definitely, if you have some secrets like AWS IAM secret key or SES users or something like this, then these passwords are in plain text. And yeah, of course, you have to hide them somehow. Yeah. Any other questions? No.
So you haven't used continuous delivery pipeline in production, if you will?
No. This is totally like greenfield.
Okay.
I'm doing this on my own and just for fun and breaking all rules which possible. But I mean, I see that it's gonna to be working, in more solid way.
Yeah. Do you see any problems with it?
With Terraform?
No, with doing it in continuous deployment sort of.
Yeah, one problem which we have related to continuous deployment is that we're not always sure what kind of how to say, if we really need to have equal environments. Let's say, do we really need to have not instances in each availability zone, even for developers, or not? There are a lot of questions which we have to solve, if this is change which I validate, and I say, okay, let's deploy it to development, that's fine. The critical point will be when we can say to developers that, okay, guys, now you don't have any access to console. Then it will be very interesting to see how people actually change their mind and understand that, okay, I have to code. I don't have to click in UI and fill in magical fields,
Yeah.
because a lot of resistance will be this time. Right now, no, I don't think we have problems related to continuous delivery. I think it will be pretty useful to test specific change set on different environments by assigning them. Let's say you have output from one plan in development, and you want to try this on different environments. Let's say we have two developers, and two developers are working on different features. So if you plan new change, it will create like 5 resources. If another developer, it will create another 5 resources of another type. And what is hard to figure out is like if this developer pushed his changes and we plan this, can I, before pushing my changes, get this small change set and try that it will be compatible to my changes, before pushing code further on? Because it can break because, let's say, I don't know what kind of limitation, but let's say one developer is removing an item from S3 bucket, but I'm dependent on this file, for example. In separate, these changes looks good, right? It's no problem.
You just have to be first.
Yeah. Yeah, I think it's going to be all right. As long as Orion is with us, it's going to be all right. Yeah. Any other questions? No.
Is there a way to get a Terraform template based on a CloudFormation template?
What do you mean, Terraform template?
If I have a CloudFormation stack or a recipe, or I don't know how to call it, template, I think it's called. Can I get a Terraform equivalent of that?
You mean convert one into another?
Yeah.
This is totally not possible. But as I showed, you can create some resources. It can be that you created them with CloudFormation. And then you realize that, okay, I want to, without deleting these resources, I want Terraform to handle that. Then you have to do magic as I showed. But automatically conversion of those, they use very different techniques. Though there is a work happening on importing generic resources, there is a project called Terraforming, which can generate, so you give your IAM permissions to it, and it will just list you resource definitions for a specific type. So you say, okay, export all IAM groups from my account, and it will create you Terraform for you. It's actually pretty good for most cases, like VPC, users, EC2, and so on. So it can create a lot of resources for you. But it doesn't do from CloudFormation to Terraform. It goes from Amazon to Terraform. It's called Terraforming. And more official way, probably like standalone commands, is coming definitely from Terraform. Because a lot of people feel it's pretty hard to get, like, okay, I have some resources. How I can just import them. So I think it will be once. Also, I didn't say anything about application deployment and how you can actually access these resources which you created. In Terraform, everything is defined in single TF state file. So what you do is that you create instances, launch configuration, and so on, which will somehow put data into this TF state file. And then let's say you want to use Ansible to access these resources. Or in another case, again, coming from HashiCorp, you want to deploy your Docker containers onto these resources using Nomad. Sounds cool, right? And Nomad is product of HashiCorp, so they thought carefully about exporting resources from Terraform into something what Nomad can consume. So this integration is going to be pretty cool. And I mean, Terraform created resources, so it's not going to keep these resources and it's my resource, I will not tell anyone. It will definitely kind of export them somehow. Maybe some other commands you can, I didn't show it, but so you can write show, Terraform show, and it will just list all resources with all properties which it knows about. So some information from here you can extract, and so show will show too much, and output will show just a little bit. Again, that's another window. Yeah, so it will just show something what is exportable from this project to another project. Any other questions? No? Okay, then probably the last slide is for all of you. Thank you.